And so let's take a look at what we have from last time. So last time I should mention how we developed the idea of the Gaussian eliminations at first, because not all of you know how to solve the linear systems of equations with the Gaussian eliminations. Let's see, what do we have here? Wow, that's a lot of printing. Let me figure out. Okay. Gaussian elimination. Okay, good. And so I should mention this. Can you see? Okay. So I should first introduce how to solve the linear system equations naturally. And the next, and then we go back to the matrix format and then solve it with the Gaussian eliminations. Let's see, this is, let me get you one example, one simple example here. This is the E1, we have the equation here, and it's just the E1. I just pick a very simple equations, but in your exams, you know, there's no such a simple equations on your exam. And this is just manually create a very simple examples in the lecture. And so if you want to solve these equations, the first idea is to reduce the variables in the equation 2 and equation 3, right? And so the first idea or the first step is to use the first equation to eliminate the x1 variables in the equation 2 and equation 3. And what would you do is to use the equation 2 to subtract the equation 1, and then use this subtractions results and then to replace the second equation. And this is the idea when we solve the system of the equation here. So first step, we use the equation 1 to eliminate the x1 variables in the equations 2 and 3. And with the equation 2, subtract the equation 1, we can get rid of the x1 here. And then for the equation 3, you can do the same thing, right? And use the equation 3 to subtract the equation 1, and then replace the equation 3 with the subtraction result. And so this is the equation 3, subtract the equation 1, and then replace the equation 3, and then we get a new system of equation. But after subtractions or addition things, and then you will find out that the system of equations are equivalent to the original one. And so now what is the new one? The new one, okay, we can keep the equation 1 here because there's nothing changing here for the equation 1. And then what about the equation 2? Equation 2, we use the equation 2 to subtract the equation 1 and then replace the original to replace the original equation 2. So what is the equation 2? We use the x1, subtract the x1 there, and then so that's the 0, plus the x2, and then subtract the x2 in the equation 1, and then we also get a 0 here. What about the x3? We have 2x3, subtract the x3, so we have this. We use the 2x3, subtract the x3 here, and now we got this. 2x3, subtract the x3 is just the x3. And then what about the right-hand side? 5, subtract the 3 is just the 2. So after the subtraction, and then replace the original equation 2, and then we got the new equation 2 here. And then what about the equation 3? We would do the same things. Use the we are going to use the equation 3, subtract the equation 1, and then we can get rid of the x1 here by this subtractions. And after the subtractions, we got 0 here, and then 2x2 subtract this x2 here in equation 1, we got x2. And what about the third one, the third component, and that is the x3. x3 subtract the x3, we got 0. And on the right hand side, we have 4 subtract 3, and then that is just 1. And this is the new system of the equation. And then this quite obvious that it's very obvious that the x2 equals to 1, x3 equals to 2, and you can go back to substitute the value x2 and x3 back to here, and then you would get the x1 value, right? But let us make it look nicer, this system. And x3 is here, x2 is here, right? Let us exchange equation 2 and equation 3 positions, and if we do the this exchange the location here, and we got this. It looked nicer because it looks like this. I'm going to do some copy and paste here, and then but now I'm going to get this to be my equation 2, and this is my equation 3, and it looked nicer because it's a upper triangular triangle here, and then all the things below here is 0. And from this system of the equation, it's really easy to solve it, and because this is just the equations we mentioned before, the lower. This is the upper right triangular system, and then we can solve it with the backward substitutions procedures. And this is how we solve the equations with some natural idea. And so from inspired by this example, and then for general matrix, we can do something similar to this. So let's take a look at here. Let's go back to here. We go back to the matrix format. The matrix format of this equation, it looks like this, but we use the augmented matrix format, which means that we put the coefficients matrix and the right-hand side vectors together, and so we got this. So augmented matrix format of this example, it looks like this. We could let all the coefficients on the left-hand side 1, 1, 1, 1, 1, 2, and then 1, 2, 1. This is corresponding to that the examples, the system of the equations in the example, and we use 1 slash here, the vertical line here, to separate the left-hand side and the right-hand side. This is the coefficients matrix. And then on the right-hand side, you get the right-hand side, so vector B here, and then that is the 3, 5, 4. And this is the augmented matrix, coefficient matrix here, and then the right-hand side B vector here. And what we did there before the step 1, step 2, and it's just the row changing. The row, you're doing some row operations here. So for this is row 1, row 2, and row 3. And what we did, so I still use the E1, E2, E3 to represent the row 1, row 2, row 3. And what we did just now is so we just use the E2, subtract the E1, that is the row 1, row 2, subtract the row 1, and then replace the original row 2. And we also do this. Row 3, subtract the row 1, and then replace the row 1, row 3. Because our goal for this set is to get the variables, the component here, below the diagonal to be 0. We want to make it to be 0. And then so that's why we did such operation here. We want to use the first row's diagonal element here, and then to eliminate all the elements below here. And so we did such operation, and after such operations, you get this. You get the new matrix. So this is the operations we get, and then with such an operations, you get a new updated matrix here. The new updated matrix looks like this, and then that's 1, 1, 1, and then 3 is still 3 because we don't change the equation 1, the row 1. And then for the row 2, we use the row 2, subtract the row 1 to replace the row 2. And so we have 0, 0. I am using this to subtract this, and then I got 0. And then I write the result here. I use this 1, subtract the 1, and then I got 0 here. 2, subtract 1, and then I got 1. And on the right hand side, you would do the same things. 5, subtract the 3, and then I got 2. And you would do the same things for the equation 3 and equation 1. So I'm going to use the equation 3, subtract the equation 1 to replace the original equation 3, the row 3. And I got 1, subtract 1, and then I got 0. And 2, subtract 1, I got 1. And then 1, subtract 1, and then I got 0. And then on the right hand side, 4, subtract 3, I got 1. And this is very nice, but our ultimate goal is to get the upper right triangulars on the coefficients matrix part. So I'm going to exchange the row 2 and row 3 here. And that's another step we did before, but before this, and then we are working on the linear system of the equations format, but here we are working on the augmented matrix format. And now we are going to exchange the equation 3 and equation 2, and then that's row 2, row 3, and then we got this. And that is 1, 1, 1, and then 3. We have nothing to do with the equation 1, and then equation 2, we got this. 0, 0, 1, 2, because I'm going to get the equation 2 to the bottom, the equation 3 places. And I'm going to move the equation 3, the original equation 3, to the equation 2 places, the locations. Okay, and I got this. And this is how we work with the augmented matrix format. And from now on, we are not going to use this format to solve the equations because you need to write the variables each time. And so now, from now on, we are going to just work on the augmented matrix format. It looks like this. We use some row operations. You can do the subtractions. You can exchange the rows. You can do some additions here as well, and then to do some operations between the rows, and then to get equivalence equations, equivalent systems of equations, and the desired systems of equations looks like this. The coefficients matrix looks like this. It should be upper right triangular matrix, and this is the desired format. And let's take a look what this is. Just the one simple cases, and then let's take a look if we have a general matrix, general system of the equations, what can we do to eliminate the matrix to an upper right triangular format? So let's go to a general cases. The general cases looks like this. So a general linear systems looks like this. First, let's define the general linear system of the equation, system of the equations. And And it should look like this. We have the coefficients and the variables. Let's say this is an n by n matrix. This is n linear n equations with n variables, n unknown variables. A2 to x2 plus d, A2n xn plus b2. And so on and so forth, we have n equation and an2 here, x2 plus ann, xn, and then bn. And you will see this. Let's translate this linear system of equations into the augmented matrix format. And okay, an augmented matrix format, augmented matrix of these systems, it looks like this. And we can write it in this way. On the left-hand side is the coefficients matrix, and then this is the B vector on the right-hand side. And let's write it in this way. First, let's write out the coefficient matrix, and then let's A11, A12, A1n, A21, A22, and then to the A2n, and A11, and then ANN2, and then the ANN, and then B1, B2, and then the BN. And then now, let's take a look at what do we have here. So we have an algorithm here to help you to do the Gaussian eliminations procedures. Wait, I'm not going to write one by one because it's not. I'm going to do some copy and paste here. So if we want to, so let's see the goal first. So the goal, the ultimate goals is to animate the left-hand side coefficients matrix looks like this, and all the rest of the things is 0 at the bottoms, at the lower bottom, lower left bottom, and then we have some. We have a new right-hand side vector here with the row operations here, and this is our ultimate goal, and we should do it one by one to achieve our goal here. And let me just copy and paste the algorithm here. And if you take a look at here, if we want to get this up to be 0, right? And you will see this. And we want to get the parts under the diagonal to be 0, right? So you can do it one by one. And then the first round, you can get the first columns below the diagonal to be 0. And then in the second round calculations, and then you can get the second column, the elements in the second column below the diagonals to be 0. And in the third round calculation, and then you can get the elements in the third columns under the diagonals to be 0. And then one by one, and then you can get all the things below the diagonals to be 0. And then you need n rounds calculation here. And this is the general idea of the Gaussian elimination. And I'm going to show you the algorithm here. And you don't need to copy down this. That's a lot. That's a lot of things here. But the things, you don't need to memorize it as long as you practice enough, and then you will get familiar with this algorithm, and then you don't need to memorize it. The procedure is just to get the 0 out one by one for each column, and then you know that, all right? And okay, so let's go to take a look at the algorithm at this moment, but you don't need to memorize it. As you practice more and more, and then you just naturally know what to do for the Gaussian eliminations. So for I equals to 1 to n minus 1, what does it mean here? So it's going to, for each step, I equals to 1 or I equals to something. And then for each I, you are going to eliminate for the I column, the elements below the diagonal. You are going to eliminate those elements for each I. So we want to eliminate 1, 2, and then to the n minus column, the elements below the diagonals. So the I index is from the 1 to the n minus 1, not the n, because the n, a and n is just the is a and n is just the a and n is just the elements on the diagonal. We don't need to eliminate it. So the I index is from 1 to n minus 1. So for each I, and then we go to do the step 2 to the step 4, and then step 2 and then step 4 is just the eliminations process. You want to get the 0 out for that column below the diagonal. And one of the very important things is that you want to use that column, the diagonal things, to eliminate the, so for, let us see, for the A11, right? And then, for examples, for the A11, we want to use the A11 value and then to eliminate all the things below to be 0, right? But what if A11 is 0? If A11 is 0, you cannot do some, if you do the subtraction or do the additions, and then it doesn't give you any changes, right? So you need to pick something that is non-zero from the first column to do the elimination. So what you need to do before you go to the step 3 is to pick one non-zero element from this column and then exchange that row to be the first row. Does it make sense? Any questions here? Because let's see one example here. Just one very simple examples, 1, 2, 3, and then 2, 1, 0, or 3, 1, 3. If you want to do the Gaussian elimination for this matrix, let us follow the process before, and then we use the equation 2, and then subtract or add some things and up to coefficient of the equation 1. But you will see that because the equation 1, the A11 is 0. If you do the subtractions or the addition there, and then you will not change the number for the 2 here. You will not change the number for the 3 as well if you do the row operations there. So what we are going to do is to go to the first column and then go from the top to the bottom to see which one is non-zero, the first non-zero element. Okay, this is the first non-zero element, right? The 2. So I'm going to exchange the row 2 and the row 3. So row 2 and row 1. Row 2 and row 1. And you will see this. After the exchange, you would get this. It's 2, 1, 0, and then 0, 1, 3, and then 3, 1, 3. And at this time, you get a non-zero element at the top. We call this is the pivot element. So this is the name for this pivot elements. We want the pivot elements to be non-zero. And the pivot elements is used to eliminate the pivot elements is used to eliminate the elements, the component here. And then we want all this component to be here to be 0 below the diagonal. And so here for the 3, this is already 0, and then we have nothing to do with it. And we don't need to do extra job to remove this to be 0. So for the 3 here, we only need to do such an operation here. And you will see we are not using the E3 subtract the E2. We need one coefficient there. And so actually we want to do 3 subtract 3, right? And then we get 0. But we are going to do this. E3 and then subtract the E1 and then one coefficient here. And you need to fill out this coefficient, and then such that after we do such an operation, and then the E3 here, the equation 3, and then for this component, this would be 0. So what is the coefficient for here? If you calculate this coefficient, so which means that for the first row and then the third row and then the first column, this element here, we want this to be 0. You want this to be 0, right? And we want to do some row operation here and up to one coefficient here. And then we need to figure out what is this coefficients. And let's just do the operations for the first element here. And then it should be 3 subtract the elements in the first row, and then that is 2, right? And what is the desired result? The desired result is 0 because we want it to be 0, right? And so now please fill in this coefficients here to make this equations to be 0. And then what's this coefficient? Can you tell me? 3/2, right? Okay, that's correct because this is just a 3/2, and then you get 3 subtract 3, and then it's equals to 0. So here we got this coefficient is 3 divided by 2, and you will see this, and then we will do the operations, the row operation here, and then we can change the things to this. We can, with this row operation, we got 2, 1, 0, and then we keep the second rows unchanged. And then what is the third row? The third row, it should be 0. And then the second element here will become 1, subtract the 3/2, and then for the element, the column, the element in the same column, but in the equation 1, the row 1. And that is just the 1 subtract the 3/2, and then times the 1 in the equation 1, the row 1. And so we got this. So after some calculation, this is just the negative 1/2, right? And we would do the same things for the third element here. It's just a 3 subtract the 3/2. We use the same coefficient here because this is the row changes, and then we need to keep the coefficient to be the same. And then 3 subtract the 3/2, and then in the same column, and then we have, but in the first equation, we have 0 there. So this should be 0. And at the end, it's just a 3. But now, after some operations, you get 0 here, and then you get 0 here. This is our goal. And then for the first round of the calculation. That's what I mean here. Before you go to the calculations, you need to do this. If you find the pivot elements, or that is the diagonal elements in your matrix, the updated matrix is non-zero. And then it's 0, and then you need to find a non-zero elements in the same column, and then you can switch that row, and then with that 0 pivot element row, and then after this, and then you can do the calculations. And those calculations, step 3 is just exchanging the row, and then the step 4 is the first you need to pick the coefficient. And that is the coefficient here, the 3/2 here. What is the 3/2? This is the pivot element, and that is the elements on the diagonal. And then we are going to eliminate the first column, and then so this is a pivot element for this round of the calculation. And now, after the exchanging, and then this is non-zero. And for the step 4 in the algorithm, it's just doing, okay, first you need to calculate the coefficient. The coefficient is just, if we want to eliminate this row to be 0, and then we need to pick this element and then divide it by the pivot element here, and then that is our coefficient, because 0 divided by 2 is 0, and then we don't need to do any calculation here, and then just skip it, or you can do it as well in the algorithm, but it will not change anything. But for the third column here, the coefficient is just this element in the same column, and then divided by the pivot element, and then that is 3/2. And this is how we choose our coefficients. And this is how we choose the coefficient. It's just the state element. So you will see this is this I column, right? We are going to eliminate the elements below the diagonal, but it's in the I column. So for this coefficient, it's just AJI divided by AII. That is the diagonal element, and that is the pivot element for the I round calculation. And for this one, it's just the eliminations process for that round, for the I round. And this is the whole process for each I. You would do the 2 and 4, and then that is just eliminations process for each column. And it's hard to see the things happening from this algorithm. So we are going to take a look one concrete example, one more difficult and more complicated example, and to see how this algorithm works. So example 1, it's hard to understand the algorithm, but actually the process is very easy. Let's go to see this example here. I'm going to say it's x4, and then this is 0. But actually in the equation, it write it in this way: x1 plus x2 plus 3x4, and then equals to 4. And then for the equation 2, we got this, and then 2x1 plus the x2, and then subtract the x3 plus the x4 equals to 1, and then 3x1 minus x2 minus x3 plus 2x4. For fourth equation, we got 4 equation here, and then you will see the coefficients equation here is more complicated than the inspired example. And so once you get such a linear system of equations, what should you do? You need to get the augmented matrix for it. And so I'm going to get a augmented matrix for it. And let's see. Let me just minimize it a little bit. Zoom in a little bit, and then go to here, please. Okay, and we got an augmented matrix for it. What does it look like? It should looks like this augmented matrix. And this is the first step. You need to get the augmented matrix for the system, the linear system. And so it should be the coefficients on the left, and then the right-hand side vector, the B vector on the right. And it looks like this. For this specific linear systems, we collect all the coefficients together. And for the first row, you get this. 1 is for the variable x1, and then 1 for the x2. And do we have more things here? What about the x3 in the first one? First equation, the coefficient. 0, yes, correct. It's not nothing, it's just 0, plus 0 times x3. And the x4, you get 3. And let's collect all the coefficient here. You can also write 4, and then that is another B vector. I'm going to use the vertical line to separate the A matrix and the B vector. And we are going to copy down all the coefficient here, and 2 for the equation 1, x1, and then 1. And then what about the x3 here? What should I put here? -1. Yes, you need to be very careful. Don't just write 1. And then this is 1, 1, and I'm not going to work one by one with you. It takes so much time. So I'm going to write out all the things at one time. Okay, this is the augmented matrix. And I finished for you. And the first step is to, so don't forget, we are going to go to eliminate these three elements. These three elements is below the diagonal. So let me just draw out the diagonal first. This is the diagonal, right? I'm going to get this to be 0 in the first round of the calculation. I'm going to get this to be 0 in the second round of calculation. And then in the third round of calculation, I'm going to eliminate these elements to be 0. So let's go to the first round first. The first round, round 1, it's like a game, round 1. Okay, round 1, what we are going to do? So the format, it looks like this. The round 1, we are going to use the row 1 to eliminate the row 2, row 3, row 4 component in the first column. So we are going to use the row 1 to do the elimination. So the format looks like this: E1, and then replace something, and then E1 replace something, and then E1 replace something. And then what is the E1? It's plus something here, coefficient, plus something here, coefficient, and then plus the coefficient here. We're going to multiply the row 1 by a coefficient, and then do the addition here. The additions, do the sum here with the row we are going to change. So we are going to change the row 2, row 3, row 4, 1 by 1, right? So we are going to change the row 2, row 3, and then row 4, 1 by 1. And then we are going to use the row 2 plus a coefficient multiplied by the row 1. And then this result, we are going to use this results to replace the row 2. And we are going to do the same things. The row 3 plus a coefficient times the row 1, and then to replace the original row 3. And for the row 4, we use the row 4 and then add the coefficient times the row 1, and then to replace the original row 4. And this is what we are going to do. And then now you need to calculate the coefficient here. What is the coefficient? The coefficient should be, so let me highlighting the elements here. So first, for the first round of the elements, first round of the calculation, this is a pivot element, and AII is just a pivot element. And then for the row 2, we are going to take a look at the elements in the same column, and then but it's in the row 2, it's just a 2. So we are going to use these elements to divide it by this pivot elements, and that is just 2 divided by 1. So we got this here. This is just the 2 divided by 1. And for this row 3, we will do the same things, and we have the elements in the third element in the first column, and that is just 3. And then 3 divided by the pivot element is just 1. And then so here we have the coefficient. It should be 3 divided by 1. And what is the coefficient here? So you would do the same thing. What is the coefficient here? The fourth column's element, the fourth row, but the first column. And then divided by the pivot element here. So it should be -1, right? And so here we got -1. Okay, I'm going to do all this row operation here below. We have 3 rows here. We are going to change these 3 rows. And let me see. So I'm doing something wrong here. I need to use the subtraction here, not the additions. This is subtractions. This is something wrong, and it should be subtractions. It should be the subtractions sign. Yes, it should be the subtractions. And next, we are going to do all these rows, perform all these rows computation here. So, but you will see I'm not going to change the row 1, right? So I'm going to just copy and paste the row 1 and just write down the row 1 here. And this is a split line. On the right hand side is the B vector. So the first row 1, 1, 0, 3, and then 4. And for the second row, I'm going to use the row 2, subtract the row 1, subtract the 2 row 1. And so that is just the 2. I'm going to do the, so for here, we got 2, subtract the elements, that is the elements in the row 1, and then times 2, right? And then that is 2 times 1 here. And for here, we got, it's just the second row, right? Second row, the original element is just 1. And then minus this, the coefficient here, 2 times the elements in the row 1. The element in the row 1 is just 1. Okay. And then for the third element here, the original element is -1. So I'm copy down the -1 here. And let's subtract the 2 times the elements in the first row. The element in the first row is 0. For this one, I have 1. The original element is just 1. And then subtract the 2 times the element, the same column element, but in the first row is the 3. It's the 3 here. And you would do the same thing for the B vector. We have 1 here. The original vector, it should be 1. And the original, and then times 2, subtract the times 2, 2 times the original vector, original elements in the E1, and then that is the 4. And you could do the calculation here. And for this one, I got 2 minus 2, and then it's just 0. For this one, 1 subtract the 2, it should be -1, right? And this is how I do the all the calculation, and this is just -1, and this is just a -5, and this is how I do the calculations. You could see all the results on the lecture notes, but maybe you would not see how I get it from the lecture notes. So you would do the same thing for the third row and the fourth row, and then I would just perform first 2 elements calculation for you here. For example, for the row 3, right? I got 3 subtract. What is the coefficient here? This calculation for the row 3, the coefficient is 3. And what is the element in the row 1 in the same column? And then it's just 1. And you will see this becomes 2, 0. And this is also our goal. We want to get 0 out from that column. And then what about the second element here? The original element here is -1. And then we are going to subtract the 3 here times the original elements in the first row. And it's just 1. And you will see this becomes -1, subtract the 3, it's -4. Am I right? Yes, I'm right here. And -4. And I'm going to skip all the calculations below. You can perform the calculations by yourself after the class. And remember to do the same operations for the B vector as well. And you need to change the B vector as well. And then, okay. And I got this. B4, 4, 1, -1, -7, 0, 3, 3, 2, 15, and then 8. And this is just the first round. And then after the first round, you will see this is all 0, right? And if you go back to take a look at the algorithm, the round 1 is just I equals to 1. Here. And we are going to, we have already go through the I equals 1, and then And we have already do the step 2 to the step 4 for I equals to 1. So next, we are going to do the calculation for I equals 2, but we repeated the same process here for the step 2 and to the step 4. And step 2 and step 3 is just a row exchange if in case that the AII is 0. So now the pivot element is, we already get this one to be 0. All the element below the diagonal in the first column to be 0. So let us take a look at the second step. The round 2, we want to get this 2 to be 0. This 2 is the elements in the second row column, but below the diagonal. And so the pivot element here, it should be -1. We are going to use the -1 here to eliminate all this to be 0. And okay, this one is non-zero, and then we don't need to do any row exchange here. Round 2, let's go to the round 2. And I equals to 2 here, I equals to 2, if you go back to the algorithm, I equals to 2. And here I'm going to say we also have some row exchange, row operation here. And what we are going to do is to get this to be 0, get this to be 0. This is row 3, this is row 4. So we are going to update the row 3 and row 4. And that's our row operation in the row 3, in the round 2. And what we should do, so we use the original's row 3 and then do the subtraction. And then we are going to use the element here that is in the second row, right? And we are going to do row 3 subtract up to a coefficient and then row 2 to replace, use this results to replace the E3. So we have, this is not just 0, this is a coefficients we want to fill out later. And then for the row 4, and then subtract the row 2 and then up to 1 coefficient here. So now what is the coefficient? The coefficient here, it should be, so let's take a look at the row 3. It should be the row 3 element here and then divided by the pivot elements. And then that is a -1. So we get this, we got, so here it should be -4 divided by -1. And it's just A32 divided by A22. And what about the this one? This one is just the same column, but in the 4th row, and that is just 3 divided by the pivot element here is -1, and 3 divided by the -1. And this is just the A42 divided by A22. And this is the row changing, row operations we want to do in the round 2. And I'm going to skip all the calculation here and then to write out the result, augmented matrix. And so up to some row operations, you get this in the round 2. 1, 1, 0, 3, 4. Because in this, in the round 2, we don't change the row 1 and row 2, and then I'm just copying them. -1, -1, -5, -7, and the round 2 also gives us this results. The row 3 is changing 3, 13, and then 13. 13 here, and what's the rest? 0, 0, 0, -13, and -13. Wow, that's such an impressive calculation. And then you will see this is the design result. And this is the diagonal, right? And let's see what is remaining in below the diagonal. Below the diagonal, we have 0, all the 0. And now that is the decisive sum of the equations. It's upper right triangular matrix for the coefficients part. And that's the design one. And after this is a Gaussian elimination process. And then we got the upper right triangular system. And then now we are going to use the backward process, backward substitution to solve the system of the equations. I'm going to use equations. Okay. So first of all, this is just negative 13 times x4 equals to negative 13. This means that you don't need to write this in your exam, but I would just tell you, okay, for explanation, and then the last row, it means negative 13 times x4 equals to negative 13. So we got this, x4 equals to 1. And what is the second, the last second row here? The second row here, from the bottom, it should be, it means 3x3, because this is the coefficient for x3. This is the coefficient for x4. We got this plus 13x4 and then equals to 13x4. 13 on the right hand side. And so we get this, and then it should be x3 equals to 30 minus 13x4 divided by 3. And you would see this is just 0. X4 equals to 1 from here. So this is just 13 minus 13, and then we get 0. And this is the backward process. We are going from the bottom to the top. And then we have already utilized 2 rows from the bottom. And let us take a look at this row, the third row from the bottom. This equals to -1, x2, and -1 times x1, -1 times x2, and then plus the -1 times x3, plus the -5 x4, and then equals to the -7. And this is the meaning of the second row, but we already know the value from the previous second row, and then a previous 2 row. We already know the x3 and then x4, and then we can substitute the x3 and x4 to there. And x3 equals to, what's the x3? x3 is just 0. And then x4 is just 1. So we got this. We got the x2 equals to -7, subtract the -5, and then, am I right here? Yes, and then divided by the -1. And this is just 2. x2 equals to 2. And we already get 3 variables, and then we just need to solve the x1. And what does it mean by the first row? The first row is just x1 plus the x2, and then plus 0, and then plus the 3x4, and then equals to 4. And we get from the previous solutions, we get this is just 2, and then this is just 1. And now we got x1 equals to 4 minus 2 minus 3, and then that is just -1. And from the backward substitutions, we have already solved for the x4, x3, x2, x1. So at the end, we can conclude that x1 here, we collect all the solution here. x1, x2, and then x3, x4 equals to 1. And that's the whole process. Use the Gaussian elimination to get the right upper triangular system, and then use the backward substitution to solve the system of the equations. Does it make sense? Any questions here? Any questions here? So I'm giving you a lot of details here because we are going to use all this Gaussian eliminations process later on. Okay. I need to do some things to save my iPad from dying. It's running out of battery. I need to save it. Okay. Please don't die before this class. Okay. Okay. Now he's safe. The iPad is safe. Okay. Go back to here. Go back to our class. Good. Good. It seems that all of you have already got what it means by the Gaussian eliminations here. And I'm going to give you one more examples in case that you cannot understand the process here. But I'm not going to do the calculations one by one. So let's take a look at the example 2. Example 2. And I'm going to just write out the linear system of the equation and with the augmented matrix. And it looks like this: 1, -1, 2, -1, -8, and 1, the split line is here. 2, -2, 3, and then -3, and -20. You should be able to write out the augmented matrix from the linear system of the equations. -1, 4, 3, 4. So once again, you are going to do the round 1, round 2, round 3, and then let's take a look. Yeah, this is the diagonal, right? And actually we want to eliminate the elements from the first row, second row, and the third row. So we have 3 rounds of the calculation. We expect there are 3 rounds of the calculation here. From the round 1, okay, round 1, I'm going to ask some people to fill out the coefficient here. So we are going to eliminate this, right? Let's take a look at here first. So we are going to use the A11 in the round 1 to eliminate all the elements below here in the first column, but below the diagonal. So here for the equation 2, and then subtract the equation 1 up to a coefficient. And then we replace it with the original row 2, right? And we also need to do the same things for the row 3 and then the row 4. And that is row 3 and row 4. Row 3, row 3, and then this is row 4, and then this is row 4. Okay, so what I'm going to ask is, what is the coefficient here for this one? So one thing is that, so the p-word element here is just A11, right? And now if you are doing the row 2, and then it should be the row 2, 1. And then if you are doing the row 3, and then it should be the A31. So this is just AJ1. So what is this? A21 divided by A11, it should be this element divided by this one. 2. Okay, it's so simple. And then but no one is brave enough to answer it. And then this one is just 1 divided by 1, and then it's just 1, right? 1. And then 1 divided by 1 is just 1. So I'm not going to do all the calculations one by one, and then I will just write out the result. And later on, you will see why I'm mentioning this example. This example is a little different from the the previous one, and then I'm going to write out the results. And then if you have difficulty in the calculations, how to get the matrix here from the, if you have some calculations, if you have difficulty in the, to get this matrix from the row operation here, you could go to my office hour, and I'm going to write out all the result here at this moment. And the things I want to point out from these examples is that, okay, so this is just the result, right? And then now we get this result, and the diagonal elements are here. And the next steps, I want to get all these things to be 0, right? But now, what is the pivot element? The pivot elements in the second round. So let us go to the second round. We have already finished the round 1, and then go to the round 2. The round 1, the pivot element is A11. And then the round 2, the pivot element is A22. That is the elements in the updated matrix, the 2 locations. But here, let's take a look at this pivot elements. And this element is 0. That is the situations we have before. What should we do? We go to take a look at this column. And then what is the first non-zero element? That is a 2, right? It's the row 3. So we are going to, so in this round 2, we are going to first exchange the row 2 and row 3. And this is the first step in the calculations. And I'm going to exchange the row 2 and the row 3. The exchange size is this one, the double-sided arrow. And after you exchange this 2 row, and then we got this. So I'm going to write down it here. And I'm going to exchange the 2 row here. And then the row 3 would be the row 2. And then the row 2 would be the row 3. Wow, that's impressive. After we exchange the row 2 and row 3, actually for this augmented matrix, we don't need to do any calculation further. We don't need to do further calculation to remove the elements below the diagonal matrix. So this is just round 2. Let's go to the round 3. The round 3. The round 3. And then what's the pivot element here? The pivot element here is the A33. So in the round 3 is the updated matrix, and then but it's in the position 3-3. And that is our pivot element. Pivot element. And pivot element is written in this way. Pivot. P-V-P-I-V-O-T. We call this pivot element. And we are going to use the pivot element to eliminate the component below in the state column. So we are going to update it to row 4. So the format of that should be row 4, and then subtract a coefficient, and this is the pivot element. The pivot element is in the row 3, right? So we are going to have coefficients times a row 3, and to replace the row 4, and we are going to update the row 4. So this is we are going to replace the row 4, and then by the original row 4, subtract up to a coefficient times the row where the pivot elements is in. And what is the coefficients? The coefficient should be this divided by the pivot element, and that is just 2 divided by -1, and then we get 2 divided by -1, and then that is just -2. And you will see this is just the E4 plus 2E3. And after the performations of this, after performing this row operation, you would get this. 0, 2, -1, 1, 6. 0, 0, -1, -1, -1, -4. We haven't any change for the row 1 to the row 3 for the third round, but we are updating for the fourth row. And for the fourth row, we got this calculation. After the calculation, we get the 0, 0, 2, 4. And now, after the 3 rounds of the row changes, row operations, and then you will see this is the diagonal. And then below the diagonal, all the elements are 0. And this is the desired result. And you cannot stop here because our ultimate goal is to solve this equation. And then the Gaussian elimination is just to help you to simplify the system of the equation. So now you need to use the backward substitution to solve the system. And from the row 4, and that is really obvious that 2x4 equals to 4, so x4 equals to 2. And for the x3, it's just the -4 minus the -1 times the x4, and then divided by the coefficients -1. So you will see this -4 minus the -1 times the x4, and then divided by the coefficients -1, and then that is the result. And that is just the 2. And what is the, am I right here? Wow. Okay, that's super interesting. I believe I have something wrong here. Okay, that's interesting. And on the lecture notes, there's something wrong on the lecture notes. I will update the lecture notes later on. And so x3, it looks like this. For the x2, and it should be just the right-hand side subtract the 1 times the x4, right? 1 times the x4, that is 1 times 2. And then -1 times the, subtract the -1 times the x3, and then that is the 2. And divided by the coefficients 2. And that is just the 3. 6 minus 2 is 4. 4 plus 2 is 6. 6 divided by 2 is 3. And then what's about the x1? The x1 is just the right-hand side b, and then that is the -a, minus the -1 times x4. -1 times x4 is 2. And 2, subtract the 2, and then times, this is for the coefficient for the x3. So x3, what's the x3? x3 is just 2. And then subtract the -1 here, and then times this is the coefficient for x2. And then we have x2 equals to 3. And then divided by the coefficient here, this is the coefficient for x1, and then it's just 1. And after some calculation, -a, this is +2, -6. -6 minus the 4 is -10. -10 plus the 3, and then that is -7. Okay, -7. And that is the final result, and we got this. Any question here? So I mentioned the second examples because we have one more step here in the round 2. We need to exchange the row to make sure that the p-word element is non-zero. And I have to mention one more thing here. For simple matrix, simple systems, we can just exchange the row and then choose the non-zero elements in the say column. But you will find out that if the p-word element is pretty small, there's something similar to the cancellations errors in our previous chapter. it would magnify the error. So actually, we have other strategy to choose a pure element. You could choose the biggest elements in this row, in this column, to be the pivot element. And that's one strategy, because something similar to the cancellation error will happen if the denominator is really small and then close to 0. For example, is 10 to the -5. And then if you, because the coefficient is just that AJI, right? It's just the AJI divided by the AII. The AII is that pivot element. And then if this one is the 10 to the -5, and then it's pretty small, something similar to the cancellation errors before will happen. And then we don't want this happen. And then you can choose that elements, instead of choose the first non-zero elements in that column, you would choose the biggest values in that columns to be the pivot element. And then exchange the row there. But there's another disaster if you choose the elements in this way, choose the biggest elements in that column. There's another disaster. And then there's another strategy to solve that problem. But we are not mentioning that at this moment. If we have more time, and then we'll go back to here to mention some remarks on this Gaussian elimination. And that's all the message you need to learn from this class. And I hope you have a happy weekend. And the next class, we would learn the LU factorizations and then the collected factorizations of the matrix. And then that's all based on the Gaussian elimination. So you need to practice on the Gaussian eliminations in this weekend. Question. What?
就我看样型这个程序，然后它这里产生的5个位置，它跟这里的不一样。这个
我看看。
我
看看，你看，go back to one, 2, 3, 4, 5，它有5个，对吧？
对，这个是5个点的那个，然后跟它这里网站上给的是
1、2、3、4、5，你 go back to there 0.05，然后那个是什么？
它这个位词它写的是这些，就这个程序运行出来的位词是在这，然后0.069，0.。
你有没有发现任何错误呢？
我刚发现它不了的负7，所以
你可以看一下，你看一下 debug 一下那个 debug 一下程序。
这个怎么 debug？
不，你就 check 一下每一行的那个 code， 它是不是 corresponding to the Crenshaw-Curtis quadrature 的？它肯定是某方面。可能是50点有
这个，
就是你看一下每一行它，就是你就是检查一下它每一行这样子插去产生这个 Crenshaw 是不是对的？它产生的点是不是对的？
产生的点我还没检查，应该是对的吧？这应该
它是1，差不多有点接近0了，这个，但是这个应该是0.7点几，然后过去那边看它，
对啊，这
0.7几嘛，然后
它这给的是
1，然后 square two divided by 2应该是1.4几，然后0.7几是正确的呀。
对，它的点是对的，但是它的权重是错的。
To weight，OK， go back to there。那 weight 它是应该是怎么算来的？它的 weight 是 integration 吗？
它 weight 是直接用公式算，就因为它这里用了 trapezoid rule，然后最后得出来大概是这么一个
对
矩阵，对啊。
然后它的 coefficient 它是怎么算的？那个 weight 我忘了。
看不起。
那你要看 weight 吗？它是 d 乘以这个 d，
我得
它是一个 matrix 的乘法，它大概就是我觉得它就是用这里的这个不是它，其实是我之前写下来的，大概是这样子写的，就是它乘的。你要 double check 它这个 matrix 有没有错就行了。
我这应该是有问题，因为它第
对
一项就不对。我第一项通过数学算出来应该是，这第一项消出来应该是这个东西，应该就是1比上 n 乘加
嗯
1。
嗯，
后面的可能不太好化简，但这个是比较好化简的。
那你 double check 一下 matrix 这里肯定是这个 matrix 里面有错了。它D0，然后0.5，它的 matrix 大概也是就是和这里差不多，但是只是说，你
它是
看一下，
相当于把第一行乘了一半了。
对
就
它 D，然后这个就是那个大 D 嘛，这个是小 D 嘛。哦，对啊，这个就是那个 code 嘛，这个 code 只是这个是那个 MATLAB 的 code，但是那个是 translate 到 Python code，可能 translate 的时候有点错了，
检查一下。
应该是 index 里面有问题，你检查一下，然后你看一下能不能把它搞。这就是 optional homework 了，所以就比较难，你要把这个 code 搞定。
好吧，这
I'm confused on like the homework a
Mhm.
little, just because I know we're supposed to change the function to e of x.
Let me see. So, let me see. We can go to
Of
the reference one. Okay, good. And then let's go back to here, and then you will see. What's your question again? You don't know how to change the function.
yeah, I'm gonna change the
So this is just I don't know. I don't think you need to change the function because it's already the exponential set. The exponential function you see. Yeah. That's the definition of the function, and then it's already well defined for your problem. You just need to run it.
Oh,
Yeah.
So what is the answer?
Yes, that's the answer.
Oh, that is the answer.
Yes, that's the answer. But that's the weights and the node points, right? And the weights, this is node points here, and then this is the f function, right? And then this is the weight, and then you got the weights and the node points, and then you need to substitute the node points into the exponential function, and then times the weights, and then do the summations for 3 node points, and then you get the answer.
Because I kind of tried to, I did get the answer, which was this, but I'm not sure that's
Yes, you can do this. You can do this. Yes, you can do this. Yes, it's approximately this one.
Oh, okay.
Are you doing the yeah, you are doing the function values and then the w here, right? Yeah, it's correct.
Oh, okay.
Yeah.
Oh, okay.
Yeah, and then for the optional 2, and then you need to just write out the format, not just, this is not coding, just write out the formula.
Oh, okay. But here,
you can type it or you can just write it on the paper and
Oh.
then submit it.
okay.
Yeah.
Also, I didn't want to go to your office hours, and like I saw that you had this. So-
Oh, I need to update the schedule online. Sorry.
Oh, okay.
Now I would update it. But you can definitely walk in my office.
I could just say go in.
Yeah, you can just go and then
Oh.
walk in. Yeah.
Okay. Thank you.
But if you have some private to discuss, and then you can make sure that tell me beforehand, and then I will make sure no one is there.
Okay.
Yeah.
Thank you.